So today we're doing lesson 8.2, function rules. I want you to copy this into your notebook. A sequence is a list of numbers in a specific order. Each number in the list is called a term of the sequence. Arithmetic sequences can be found by adding the same number to the previous term. In geometric sequences, each term is found by multiplying the previous term to the same number. So if we had this one, let's say I had 3 and then 6, and I had 3 and then 6. What term comes next in the arithmetic sequence, Alinza? 9, exactly. But let's see next. Which term comes next in the geometric sequence, Fernando?
3.
Not 3. That's a good guess, though. Lucy? Not 18. Again, a really good guess, Romario. Yes. 12. Now, how did you get 12? How do we get 12, Malia?
3 times 2 is 6, 6 times 2 is 12.
Yes, because in this one, we were doing a times 2 sequence. In this one, we were doing a plus 3 sequence. So in the first one, in arithmetic, we're doing addition. That's how I remember it. Arithmetic, addition. Geometric is the other one. That's how I remember it. So here's our warm-up. I want you to figure out if this is arithmetic or geometric. The China Palace sells lunch for $6 with a delivery fee of $5 total. Solve. So for one special, it costs $11. For 2 specials, it costs $17. For 3 specials, it costs $23. For 4 specials, it costs $29. How much does it cost for 5, 6, and 7 specials? Tobias, what kind of sequence is this?
It is a...
So yes, it is an arithmetic sequence. So let's see. What would be the first value, Rafi? For 5, what's the value? 35. What's the value for 6, Jasmine? Yes, 41. And then lastly, Miles, what's the value for that 7?
47.
47. Exactly. So, by the way, this formula would be written as y equals, it would be,
Plus 6.
yeah, it would be x. So we would have, it would be y plus 5 equals x plus 6 a little bit. I guess, I don't know. It's a little complicated because of the way that it's only got the 5 the one time. Don't worry about it.
Y times 6.
So now we are working on identifying the pattern. Okay, so we use an X to write an expression for the pattern, and we use our special words, arithmetic and geometric. These are our key words. So for this case, 7, 14, 21, 28. What are the next 3 numbers? I'm going to call on sticks. Ready? Next 3 numbers. Adriana,
Next 3 numbers.
what's the first one?
35.
Perfect. 35. Next number, Romario. 42. And next number, Ben. 49. So is this pattern arithmetic or geometric? What do we think? Raise your hand, Romario. Yes, it is arithmetic. What about this one? Let's find the next 3 numbers. Raphael. So it's not 24. What is it, Romario? It is 32. Anita, what's the next one? 64. And then Ben, what is the next one? 128. Excellent. So this one is geometric. And what's the pattern? Hannah? Times 2. What's the pattern here? What is it, Michelle? Plus 7. Excellent. I want you guys to go to page 588 and try, or do A, B, C, and D. And when you finish, try E and F. So let's look at these problems. A. So, what are the next 2 numbers in the pattern, Michelle? And 60 and 75. Excellent. And that is what kind of pattern, Lily? It is arithmetic. And what is the what is the pattern that we did, Jaden? What's the pattern? Perfect. Plus 15. B. What are the next two numbers, Jenna? And 2. Excellent. What kind of pattern is it, Emerson? Jasmine, what do you think it is? It's not geometric, so it is, Rocco? Arithmetic. And what is our sequence that we are doing, Lucy? Minus 5/10. Excellent. What about this pattern? What are the next two numbers, Nathan?
Next two.
Yes. So it is 81, and then it is 243. What kind of pattern is this, Malia?
Geometric.
It is geometric, and what is it by?
Times 3.
Multiplied by 3. What are the next two numbers in this pattern? Liam. What is it, Lucy? 48 and then 96. What kind of pattern is that? Gore. Geometric, and what is that by? Times 2. So remember, our geometric patterns can be times or divided, and our arithmetic patterns can be add or subtract. Because remember how those are the same things? We keep learning that. So what about these ones? Here's the position and here's the value. So we have 2, 3, 4, 5, and the nth term. We have 2, 3, 4, 5, and the nth term. So we have to figure out, what would that nth term be? For 2, we get 12. For 3, we get 18. For 4, we get 24. What pattern is happening here, Romario? Perfect. It's times 6, so it's geometric. So what is the term going to be for... It's not plus 6. Even though the value is going up by 6 every time, it's times 6 this way. It's 6 times its position. So Romario is correct. So what would it be for n? What would it be for n, Lucy? It'd be 6n. Exactly. It'd be 6n because we don't know what n is yet. What about this one? We have 3, 7, 4, 8, 5, 9, 6, 10. What would this kind of pattern be? Arithmetic or geometric? Who can tell me, Romario? It is arithmetic, and what is it? What is that sequence? What are we doing to it? Hannah? Plus 1. So then what is the n term gonna be? What is that n term gonna be? If this one was times 6 and we got 6n, and this is plus 1, what are we gonna get, Lily? Yeah, we're gonna get n plus 1 because we're adding that 1. Excellent. So let's look at number 4 together. We're gonna look at number 4. So, the table shows the number of necklaces Ari can make based on the number of hours she works. Write a function rule, aka what we just did, that's xn, that n, like whatever we did, that 6n, the n plus 1, to find out how many necklaces she can make in x hours. So, in 1 hour, she can make 5 necklaces. In 2 hours, she can make 7. In 3 hours, she can make 9. In x hours, how many can she make? This is a little bit tricky. I'm going to give you a hint. You are going to have some multiplication in this and some addition in this, okay? You are going to have some multiplication in this and some addition in this, okay? So it even says the answer. Here's what we see. On this side, how much does each value increase by? How much does it increase by, Rocco?
2.
Perfect. It's a plus 2, right? It's a plus 2. It goes up by 2. So the rule is going to include a 2x. But if we have 2 times x here, we're only getting 3. Or we're only getting 2. So what are we still missing? We're missing that 3, right? So we need to add that 3. And we can check it. What is 2 times 2? Show me on your fingers. 4. Add 3 to that. What do we get? 7. Hey, look, that's that answer. What's 2 times 3? Raising your hands. Rocco. 6. Add 3 to that. What do we get? Andrew? 9. Hey, look, that works. If we have x, 2x plus 3. So that's how we get that formula. Now, I want you to go to page 590 and do numbers 1 through 3. Page 590 and do numbers 1 through 3. On the hour side, how much do I increase by? On the hour side, how much do I increase by, Matthew?
You increase by 1.
Exactly. Every time I go up by 1. What about on the necklaces side? How much do I increase by, Hannah? Perfect, by 2. But if we notice something, did I start with just 2? No. I have that 5. So what's the difference? What's the difference between 5 and 2? What is the difference, Gloria? 3. So I know I've got that plus 3 to even it out, right? And then I'm going to have 2x because it's going up by 2, and this is going up by 1. So it's multiplying 1 by 2. So I'm multiplying that 1 times 2. I'm going up by 2, but I can't forget to add that 3 because without it, she automatically started with 3 necklaces somehow because she's magic and just poof, had 3 necklaces. Yeah, she had a starter set. So this is an easy way to figure it out. You look at how much it increases and then you find the difference. So continue to work on numbers 1 through 3 and I will come around to help. Actually, Fernando pointed something out to me. This problem is going to be n plus 4. It's going to be n plus 4. Because if we look at our numbers, 3 plus 4 is 7. 4 plus 4 is 8. 5 plus 4 is 9. 6 plus 4 is 10. So n plus 4 is our next one. It's not n plus 1. I actually made that mistake. So that's why I like it when my students correct me. It's actually n plus 4. Okay, Fernando, what are the next 2 terms for number 1? Excellent. And what is that kind of pattern? Geometric, and it's times 2. What about the next one, Romario? All right, what's the third term?
800, 832.
Excellent. Romario did catch me because it says next 3 terms, and it's geometric times 2. What about this next one, Gloria? What did you get?
I did 2 times x.
Excellent. It's going to be n times 2. It's geometric times 2. This last one, the last one is 2x plus 1. Your homework is page 591, numbers 1 through 13.